So yeah, we're going to talk about our specific case that we made for one of our clients, and we're going to talk about two things that you already seen this morning. So it's well placed in the schedule. So this is the title that already has been said, and just allow me to make just 2 minutes about who we are. Good Rebel is a digital strategy and creative company, and we help our clients to innovate in the intersection of people, brands, and technology. These numbers just to have an idea of the size of our fleet. The biggest ship is in Madrid, but we also have base camps in Barcelona, Mexico City, and Brighton. And this is what we do. There are a lot of things here, but I just want you to remember just 3 things about us, and Good Rebel is data, creativity, and technology. So this is us, and this is our case. That's more, I guess it's more interesting to you. And our case is a big company in the retail sector. It has 76 stores just in Spain, also has abroad, but we're going to focus just in Spain. It has a powerful e-commerce, and it buys and sells products to its customers. This is important because it's not only selling things, but also buying from them. So it's like, it makes a bit complex, the business. So this is our general question, to have clear from the above what we're going to do. So how to improve the e-commerce performance through digital marketing using offline information. We're going to use offline information, but of course, if we had the online information about the e-commerce, we're going to use it too. So it's important that we gather all the information that we have and we put it all together to see if we can make something. So what data do we have? We have e-commerce data about the client location, about the transaction price, about the purchased item, and where the item is stored. So that talks about online world. We have also the stores, info about the visits to the store, the physical visits, about the opinion of the store in Google reviews. We'll see that that is important in our project, and the location. Of course, we can see that we miss the billing information about the store, but if you work with clients, you will know that it's sometimes difficult to gather all the information because sometimes it's, whatever reasons, you don't have it. So this talks us about offline world. But is that all? No, because we can go further and have more information about zip codes levels, so about the location of the zip code, the population of the zip code, the average spend per home, the income per home, and the background where this zip code is located. So that's it's external and geographic and demographic information that we can add to our system. So our tools, we're going to use here Python to gather all this information together and try to set them like similar so we can interact and we can merge and so on. We have Tableau to visualize and try to extract insights directly from the plots. We have a geographic information system because we are talking about zip codes, we're talking about distances between places, about population, so it's important to have a powerful tool about this. And of course, the gem of the crown, we will use BigML. But always we talk about tools, and in a machine learning project, most of all, when we talk about tools, it's important to have in mind that it's like in a kitchen. You can have a very good knife, you can have a lot of very good things, and even you can have like a very powerful robot machine, like could be BigML, that's make very good things for you, but you also need a good cooker. So it's important to know that what are tools, and there's always necessary to have some mind outside there to work with all the tools to have a good recipe. So this is our project. Now we are focusing, going to the specifics. So we're going to cluster the territory based on this zip code basis, to cluster the territory to optimize the digital marketing strategy. So this is not just to improve the e-commerce, but something very specific, so we can do this stack properly. So let's go into the data exploration from the beginning. Now, this is just a map of Spain. I don't know if there are somebody from Canary Island here. Well, sorry, because they are normally outside very far here, so we didn't put in map, but it's okay. I think for pedagogical purposes, it's okay. It's included in the data, it's included in the model, so we take it into account, but we don't paint it. So we have around 12,000 zip codes in Spain. Some of them are small, some of them are bigger, and this color here is the population of the zip code. As we see here, for example, I'm from Extremadura, but in this region, it's not a very huge town there. It's just that the zip code is big. So it has a lot of population. So we have to do, out of these 45 million people, we have to do some work here to try to transform that into the background. So we don't check only the population that lives in the zip code, but how many people lives in a 5-kilometer circle around the centroid of the zip code. So now you can see Madrid here, Barcelona, you can see Bilbao and San Sebastián, and of course Sevilla, where we are now. So that looks like more than like the map of cities on population that we are used to see in Spain. So now over here, what do you think these black points are? So they are the 76 stores we have with this client. And it seems like normal that they put the stores in big cities because it's something that everybody does. And let's check the area of influence of every store. So we paint here the distance to the nearest store. So this is like the area of influence, like in orange, and the blue is where you have a store like very long from your home. So, but this is, I mean, if you see that this is like it's just a representation. So we see that like the area of influence that this representation gives us is like too ambitious. You don't go 100 kilometers just to buy something. So we just paint it differently, and that gives us another idea. So this is like the area of influence of each store is really smaller. And now we are going to make the assumption that we focus on 20 kilometers as a limit. I mean, if you live in a town that you have a store like 20 kilometers to the next town, you might want to go there because maybe you go all the days just to work or to some other store or to visit a friend. So this is an area of influence that we think that might be of interest. So we just divided here the territory in two groups, blue and orange. Blue, you don't have a store near. Orange, you have one. This is, for the moment, just an assumption. And just let's check because if you see here, the blue one, the blue part is really bigger than the other one, really larger. But the population, as we see here, is located in the orange part. So this is the distance from the nearest store. And this is the population that lives in the zip codes of this distance. So you can see that around 25 million people, this is more than the half of the population in Spain, have a store in less than 20 kilometers. So we just go to Tableau, we put our zip codes in this plot, where we check the population and the bill that they live in the e-commerce. And we see that this, I don't like to make this like a, when we see this cloud of points, it's difficult to make a regression, but we can make the effort, and we can paint these two lines about those that they are the blue, that don't have a store, and those that it has. And we see that there is a small difference between them, but if you go to the inverse bill, this is how we call that, the things that you sell to the store, the difference is even bigger. So just like we are creating an hypothesis here, and there is an awareness problem in places far away from the store. So it's just like a starting point, it's a mix of discovery and starting point is this assumption with we are going to work in this project is just that. So as a first analysis segmentation, you don't need to go to BigML to do that. We just separate Spain into groups, those that have a store in less than 20 kilometers and those who that don't have. Why we do that? Because for the data that we are going to assign to our model, you need to take into account the store. And if your store is really far, it doesn't affect to your life or to your e-commerce, we think that you don't need to put that into the model. So just to see the two groups that we have in population, it's divided like that, 25 and 20 million people. Like the customers, we see that the proportion of customers of the online, the e-commerce, it's bigger related to the proportion here. Of course, the estimated income, as we are talking about cities, it's larger also. And the e-commerce bill, it's even larger, so we see that there is a difference between the two groups here. So let's attack the two groups separately. Why is that? Because as I said, for the places far away from the store, we have the info about the place, the e-commerce, and the demographic information. But for the places near the store, you can put also the info about the store. And let's check after what info do we have about the store. But let's begin with the easy one, that is those that are far from, because it's easier because we have less data. And let's just go to BigML. It's here we put the robot machine in action, and it's very easy from now on. You configure the source here. You go to the filtering to make the data set. Just put the distance here. Sorry, because some parameters are in Spanish. You put the 20 kilometers here. It's in meters. So you make the first data set around with those that are greater than or equal to this distance. Push the button. You make a key-mean separation clustering, and we have these 6 clusters here. In this case, is this cluster 5 that has this card of parameters that talk about this cluster. So we go to this magnificent tool that BigML has that we discovered not far ago. That is, you just go to download Tableau and it goes directly into Tableau. That you don't have to mess it with TVS or something. So we just open it here. And for example, you can paint for the 6 clusters we have the inverse bill versus the e-commerce bill. So at first thing we see here is like you have like good customers here with high bill in both parameters, and those that maybe they don't interact much with the e-commerce. So as a first conclusion, you can divide your strategy and try to make some cross-selling, for example, to those guys here. And to those, maybe we just, hey, I'm here. You have an e-commerce page, website. You can go and see if you like something. So the strategy just, you see here that has to be different. So, but at the end of the day, what you have is 6 cards for those clusters that are, I remind you, far from the store. So it's not the whole Spain here, but this half that are far from the store. And you have 6 cars with different environment, with different consumption, with different income. So you just go to your strategies and tell them what is your cluster group and how to define a campaign specific for those guys. I remind you that some platform like Facebook, for example, can give you the possibility that you make a campaign in precise zip codes. So it's focus your segmentation directly where you want to go. So this is the first group, but you can paint them so at some point that you don't have like a mess of all the colors. So you see here that there's some logical distribution around the cities, in the coast, these big groups where you don't have a lot of population here. So it makes sense in a geographical representation. So, but let's go back again to those 2 groups, and let's focus now in those that has a store. It's a bit more complicated, but not that much. So we see that the income is bigger and the e-commerce is bigger, but most of it, they have a store near. So we have information about the store, and we can include, and we should include that in the model if you have the information. So what we have used here is the Google reviews. You know what it is when you go to a place and we're selecting Google Maps, you can make some from 1 star to 5 and leave a comment. So for example, this is from the business school we are here now. And this is some magnificent business school based on entrepreneurship. I don't know how you say that. So we use the Google reviews that has, we have more than 10,000 reviews from the stores, the 76 stores, and rating from 1 to 5, and text. So when you see the text here, you have the review ID, the rate, and the text. This is in Spanish. Some of them are in English. We did it for Spanish. If this is in English, the model didn't get it at all, but there is just a few in English. So if you have this text, who are you going to call? You go to topic models. So we already seen these topic models this morning. We don't go into the detail how you do that, but we just tell you that we selected these 6 models, the 6 topics here: prices, buy and sell, second-hand, complaints, process, client attention. So, and we assign to, well, we can paint it in another presentation here. But at the end of the day, you have all the reviews here, you have the rate of the review, and you have the probability that each review talks about one of each topic. At some point, at this point, we don't want to talk about the reviews, but the store. So you have to try to go back one level and make some small code to assign to the store the average rate that each store has in each topic. So we select for each store only the reviews that pass the cutoff probability 30%. So it's most likely that the review is talking about this topic. For example, if it talks about complaints and client attention, it will have half and half, for example, and will pass. So we'll assign this review to talk about this topic. So you can have for each store the number of reviews, the average rate for all the reviews, but as you see here, they don't separate too much. But if you go to different topics, this average rate can have like a very low in processes and higher, for example, in prices. So you have like a qualification for each topic for each store. That's important because at the end of the day, you want to assign this information to your area of influence of the store, and you need to know how well the store is doing in every topic. So we see this map again. So we now have the stores, but it reminded you we were talking about zip codes. So you assign, because with this great work that our specialist in GIS, Sergio, did with the GIS, so you can know which store is the nearest to your zip code. So you can assign to the zip code the information about this store. One can think that maybe, for example, for places like Madrid, you can assign the information of several stores to one location, but for simplicity, we did it this way, and more or less it works, so it's okay. So we go back to the data set with all this information aggregated over the zip code, and you make the same thing. You go to the data set with less than 20 Ks of distance. You make the clustering. You can represent it even in BigML. You don't have to go to Tableau to have these nice plots to see how your parameters separate or have these clouds. And you have, again, your cluster. In this case, you can see here there is this guy over here that is really far. But again, you have your 6 cards with the info about now you have like a richer information about your cluster, and you can go to strategies and tell them, this is our cluster, this is the zip codes where they are, go get them and make a campaign that is specific for them. So we can paint into here, you don't see the large population, you just see the points around the stores here, but if we focus, for example, in Sevilla here, we can see that there are these 2 groups. It's not only Sevilla, but the area of influence. We can see here also in Madrid, all these stores that we have here distributed in all the neighborhoods. Or maybe Barcelona, we can see that this is another store outside Barcelona, and this area's influence is divided. In the cities, you have like more different colors, but it's easy to separate them because there are a lot of population in each one. So this is what we have done. We have divided the territory in 12 groups. So each one has its own campaign specifically dedicated to the profile. So in conclusions, we can say that the awareness problem in zip codes far from the store that we have attacked separately. Info to improve campaigns by location. We have mechanisms to do cross-selling between e-commerce and a store because you have all the things related of the information about those worlds. And we associate territory with characteristic to customers. So if you know that your people that are already customers live in some place, you might not know things about the customer, but you know things about the zip code. So you might think that they behave like like the neighborhoods they have. And the reviews are analyzed to help stores also to identify strengths and weakness as like a bonus track to them so they can improve the performance. And just to take away, that's what the conclusions for our clients, but here, just to talk here, all machine learning projects need work. You need to work hard on the data, the sources, the format. You need expertise on the field, because if not, you are working blind. You need the basics of math and statistics, but the most difficult part can be simplified if you use tools like BigML. So that's was all. Now, if you have questions here or to my email, it's okay.